Hello everybody and welcome back. My name is AaronTheSloth and today we are back with another CompTIA A Core 1 Level Up Series episode. Today's episode is Wireless Networking Explained. Have you ever wondered why your phone sometimes gets blazing fast Wi-Fi in one room, but then barely loads a web page in another? Or maybe you've noticed that there are different Wi-Fi names, like Wi-Fi 5, 6, or even 7 now, but you're not really sure what those mean. Today we're going to be answering all of those questions. By the end of this lesson, you'll understand how wireless networking works, what all of these wireless standards actually mean, how routers, access points, and modems fit together, and most importantly, how to troubleshoot common Wi-Fi problems that you will absolutely see on your CompTIA A+ and in a real IT support job. Let's jump in. In the last episode, we talked about networks using cables, but Wi-Fi works a little bit differently. Instead of sending information through copper or fiber optic cables, Wi-Fi sends data through radio waves. Now, think of your favorite FM radio station. The music travels through the air until your radio picks it up. Wi-Fi works in a very similar way. Your router or wireless access point constantly broadcasts a radio signal, and devices like your laptop, phone, or tablet listen for those signals and connect when they recognize a network that they have permission to join. Every wireless network has a name. This name is called the SSID, which stands for Service Set Identifier. It's simply the name that you see when you open the list of available Wi-Fi networks. For example, Starbucks Wi-Fi, your home network, or guest network. Those are all SSIDs. Most wireless networks use something called infrastructure mode. That means every wireless device communicates through a central device, usually your wireless router or access point. Then there's another method called ad hoc mode. Instead of talking through a router, devices connect directly to one another. It's much less common today, but you should still know the term because it occasionally will pop up on certification exams. Now let's jump into our first CompTIA style question. What does SSID stand for? Secure Signal Identification, Service Set Identifier, Signal Security Device, or Shared Service Internet? The answer is B. Service Set Identifier. Now, some of these questions are very blatantly straightforward, but you will see some of these on your test. They may count for much less points than other questions, but you should still be able to identify basic vocabulary terms for your CompTIA A+. Let's talk about wireless standards. When people say they upgraded to Wi-Fi 6 or Wi-Fi 7, they're actually referring to different versions of the IEEE 802.11 wireless standard. Over the years, these standards have continued improving. Instead of trying to memorize every speed and frequency, focus on understanding the progression. We started with 802.11a, and then we moved to B, and then G. These were the early wireless technologies. Then came 802.11n. This was a huge improvement because it introduced a better range and faster speeds. After that came 802.11ac, which today we simply call that Wi-Fi 5. Wi-Fi 5 dramatically increased wireless performance and became extremely common in homes and businesses. Next came Wi-Fi 6, officially known as 802.11ax. Wi-Fi 6 isn't just about faster speeds. It was designed to handle many devices connected all at once. So think about your home. Think about phones, tablets, gaming consoles, streaming devices, smart TVs, doorbells, thermostats, security cameras. Your wireless network might have 30 or 40 connected devices today. Wi-Fi 6 was specifically built for environments just like that. The newest standard is Wi-Fi 7, officially called 802.11be. It offers even lower latency, faster throughput, and better performance for future devices. For the A+ exam, you don't need to memorize every technical specification. Just remember that newer technologies generally mean faster speeds, greater efficiency, and better support for multiple devices. Question 2. Which wireless standard introduced Wi-Fi 6? 802.11n, 802.11ac, AX, or G? The answer is C, 802.11ax. Again, for your test, you might just want to memorize as much as you can on a little cheat sheet and then try to verbal vomit all over that page. Make sure you do this before you hit start on your exam. Some testing centers may be kind of against it, but I've never ran into a problem. Now let's move on to 2.4 GHz versus 5 GHz versus 6 GHz. This is one of the biggest topics that you'll encounter in both the A+ exam and real-world IT, which is understanding wireless frequencies. Most modern routers broadcast on multiple frequency bands, so let's compare them. First up, we have 2.4 GHz. This signal travels farther than others, and it also passes through walls much better. Now the downside is that it's much slower and much more crowded. So things like Bluetooth devices, microwaves, baby monitors, and many older wireless devices all operate on 2.4 GHz. Next up is 5 GHz. It doesn't travel quite as far, but it offers much faster speeds and significantly less interference. This is why many laptops and gaming consoles prefer connecting to the 5 GHz network whenever possible. Now finally there is 6 GHz. This is the newest frequency and it's used with Wi-Fi 6E and Wi-Fi 7. Because very few older devices use it, the airwaves are much cleaner. This means lower latency and faster communication. The trade-off is the range. The higher the frequency, the shorter the distance it typically travels. A simple way to remember this, 2.4 GHz equals the best range, 5 GHz equals faster speeds, 6 GHz is the fastest speed, but it has the shortest range. Question 3. Which wireless frequency generally provides the longest range? 6 GHz, 5 GHz, 2.4 GHz, or D, they all travel equally? The answer is C, 2.4 GHz. Now let's talk about protecting your wireless network. Not all security protocols are created equal. The oldest security protocol that you will hear about is WEP. WEP is considered completely broken today. If you ever encounter a network that still uses WEP, it should be upgraded immediately. After WEP came WPA. It improved security, but still relied heavily on TKIP encryption, which also has weaknesses. Next came WPA2. This introduced AES encryption, which remains very secure and still widely used. Finally, we have WPA3, which provides stronger encryption, better protection against password guessing attacks, and improved security for modern wireless devices. If you're setting up a wireless network today, WPA3 is your best choice, whenever all of your devices support it. If some older devices don't support WPA3, WPA2 is still a very solid option. While you're configuring your network, it's also a good idea to create a separate guest network for visitors instead of giving everyone access to your primary home network. Question 4. Which wireless security standard should you recommend today? WEP, WPA, WPA2, WPA3. The answer is D, WPA3. Now let's talk about network devices. People often confuse the devices found in a home network, so we're going to clear some of that up. A modem connects your home to your ISP. Think of it as the device that brings the internet service into your home. The router creates your local network and directs traffic between your devices and the internet. It also assigns IP addresses using DHCP and determines where network traffic should go. A switch expands your wired network by adding more Ethernet ports, allowing multiple wired devices to communicate efficiently. A wireless access point provides Wi-Fi access to your network. Many home routers have a built-in access point built in, but in larger businesses, dedicated access points are installed throughout the building for better wireless coverage. A firewall filters network traffic based on security rules, helping to block unauthorized access while allowing legitimate traffic through. A mesh Wi-Fi system uses multiple nodes that work together to provide seamless wireless coverage throughout a home or office, reducing dead zones. A repeater or a range extender rebroadcasts an existing Wi-Fi signal to extend its reach. It's a very simple solution, but it can reduce overall performance because it's retransmitting traffic. A bridge connects two network segments together, allowing them to communicate as though they were on the same network. Finally, a gateway connects networks that use different protocols or architectures in many home environments. Your router also functions as the gateway, serving as the path from your local network out to the internet. Question 5. Which device forwards traffic between different networks? Is it a switch, a router, a hub, or a repeater? The answer is B, a router. Not every internet connection is created equal. Cable internet uses the same coaxial cables that many television providers use. It offers good speeds and is widely available in suburban and urban areas. Fiber internet uses pulses of light transmitted through fiber optic cable, and it provides extremely high speeds, low latency, and is generally considered the best option whenever available. DSL uses traditional telephone lines to provide internet access. While it's slower than cable or fiber, it remains available in some locations where newer infrastructure hasn't been deployed. Satellite internet connects through satellites orbiting the Earth. It's a valuable option for rural or remote areas, but often has higher latency due to the long distance signals must travel. Cellular internet uses mobile networks like 4G LTE and 5G to provide internet access. It's commonly used for smartphones, hotspots, and backup internet connections. If somebody asked you which technology generally provides the best performance, the answer is fiber, thanks to its high bandwidth and low latency. Question 6. Which internet connection generally offers the lowest latency? Satellite, DSL, fiber, or cellular? The answer is C, fiber. Now moving on to common Wi-Fi problems. As an IT technician, you'll be called because the Wi-Fi isn't working. That could mean many different things. Start by determining whether the issue affects just one device or multiple devices. If only one device has the problem, check whether it's connected to the correct network and has a valid IP address. Remember, an APIPA address is one that starts with 169.254, which indicates that the device couldn't obtain an IP address from the DHCP server. If multiple devices have no internet access, the issue may lie with the router, modem, or even your ISP. Don't overlook simple causes like an incorrect Wi-Fi password, a weak signal, or interference from nearby devices or outdated router firmware. A systematic troubleshooting approach will help you identify the root cause instead of just guessing. Question 7. A laptop shows connected but no internet. What is the first thing that you should check? There are multiple answers to this question because it is just a basic troubleshooting problem, but you would start by verifying the IP address, ensure the device received a valid DHCP lease, test DNS resolution, confirm other devices have internet access, and determine whether the issue is isolated to the device or it affects the entire network. Now, today we covered a lot of ground. You learned how Wi-Fi communicates using radio waves, what an SSID is, how wireless standards have evolved, the differences between 2.4, 5, and 6 GHz, modern wireless security, the roles of common networking devices, internet connection types, and some practical troubleshooting techniques. These concepts will appear frequently on the A+ Core 1 exam and form the foundation of many real-world IT support tasks. In the next episode, we'll continue building your networking knowledge by exploring cloud computing, virtualization, and modern network services. Topics that are becoming increasingly more important in today's IT environment. Thanks for watching. Don't forget to leave a like and comment down below if you found this video helpful, and consider subscribing to my channel. I promise you it helps. As always, keep learning, keep building, keep leveling up, and I will see you all in the next episode.